Okay, we have done Chroma Alpha on the reliability of data. Now we're going to do the normality. We're going to test the normality of the data, whether the data is normal or not, and it will actually determine whether we should use parametric analysis or non-parametric test. Okay, but before that, we need to transform all this data. We need to compute, so we go to transform, and then compute variable. So we're going to have our target variable, so we're going to do our dependent variable first. We're going to calculate the new variable, so we're going to put it like this, dv awareness. Okay, so we go here, statistic, we find mean. Okay, we double click here, so the first one awareness, so this will be, just double click here, A. Okay, next one A2, next one A3, A4, A5, A6, A7, A8, and last one A9. So what will happen here is that it will be we're going to get just one data, which is mean for the whole of awareness. Yeah, so we're going to click OK. Okay, so we can see it here. We have to look at this. Okay, data view. Okay, we have the awareness. Okay, next we're going to continue with sources. Then we're going to compute new variable. Compute variable. So we're going to reset here. So the new variable is IV sources. Yeah. So statistical, we take the mean here, double click. So remember, we have decided to delete S1 due to the reliability of data. So for sources is only 4. So we're going to do the S2. We're going to consider S2. And then next S3. Next one S4. And then last one, which is S5. Yeah. So, okay. So we have new, data, which is the mean for the sources. So we're going to compute another one, which is we set here again. So which is IV knowledge. Okay. So we still take the statistic mean, double click here. So K1. Next one, K2, K3, K4, K5. Okay. So, okay. We can see here. So, knowledge. Then, sources, knowledge, and last one, which is restriction. Okay. So, transform. Compute variable, reset here, IV, restriction, statistical, mean, R1, next one, R2, R3, R4, R5. Okay, so we have a new variable. This is the mean for everything. For this one for awareness, this one for IV of sources, this one for knowledge, and this one for restriction. Now what we can do, we're going to test the normality of the data. So we're going to do the analysis. Yeah. So analyze descriptive, descriptive statistic, and then descriptive. So we're going to take all these new variables. Yeah. Okay, all these 4 variables and put it here. So you go for option. We're going to check the mean, standard deviation, Okay, so kurtosis, skewness, and then continue. Okay. So this is the descriptive statistics, and what you can do, we're going to transfer this data into that particular here. Okay, we're going to transfer it here. Okay, we're going to check the skewness and kurtosis. Okay, and then if you see scale, so this is the mean, variance, standard deviation, and this one for this one, no, descriptive. Okay, we're going to transform all this data here into our paper. Okay, so we have the mean, standard deviation, skewness, and kurtosis for every variables. Okay, we can see that our skewness is between -1 and +1, and kurtosis is also between -1 and +1. Okay, this is kurtosis. Now, here, this one is up. Okay. Now, according to Josh and Mallory, 2010, or Hare and Breen, they argued that data is considered to be normal if the skewness is between -2 to +2. So, is it normal? Yeah, if you can see, 0.178 is somewhere near 0.0. Okay, and it's basically is somewhere very near to normal. And kurtosis is between -7 to +7. We can see that our kurtosis is between -1 and +1. So we can easily conclude that that these are all normal. So normality can be assumed for awareness. It can also be assumed for source of information. It can also be assumed for knowledge, as well it can be assumed for restriction. You can see this one, you can put it here if there are problems, but we are not going to put it here because this is sufficient to show that our data is normal, because there was an argument that absolute skewness greater than 3 and kurtosis greater than 10 may indicate problem. But for our paper, for our data, we don't have any problem, so we can assume this is actually the data is normal. Okay, so that's how we can conclude on the normality of data. So basically, we are going to delete here. Okay.